To this channel. So in today's video I'm going to be talking about something called atoms, and this is a Bohr diagram of an atom. It consists of protons, which is in the nucleus in the middle, and electrons out here. So protons have a positive, you can't see that. Protons have a positive 1 charge, neutrons have a neutral charge or 0, and electrons have a negative charge. So today I'm going to be doing a deep dive into these things called atoms and why they're so fundamentally important in chemistry. Okay, so I have 2 carbon atoms right here, and the reason why these are carbon atoms is because they have 6 protons in their nucleus. 6 protons in their nucleus. And why are atoms so important? And that's because of something known as atomic bonding. And they form these things called ions. So these 2 valence electrons, the outermost electrons on the outermost shell, well, that makes sense, they actually bond. And they bond because according to the atomic structure. Now, I don't know if you understand what I mean, so I'm going to do a little demonstration. So, first of all, there's 2 energy levels to this atom. The first ring and the second ring. And in the first ring, the atoms are happy if they get 2 valence electrons. Well, not valence actually, but just 2 electrons. And here, 1, 2. They have 2. So the first ring is happy. For the second ring to be happy, it wants 8 valence electrons. And valence because it's on the outermost shell. And right now it has 1, 2, 3, 4. It only has 4, but it wants 8. So it needs to bond. And that's why it bonds with other atoms, which make up everything we know of. One of the most common molecules to form is something called CO2, which we commonly know as carbon dioxide. And carbon dioxide forms something known as covalent bonds, where they want 8 valence electrons, but carbon only has 6. So it wants to gain valence electrons. And how does it do that? Through chemical bonding. So I brought my handy dandy hair follicle. This hair follicle is about 100,000 nanometers in diameter, which is incredibly small. But what's even smaller is these atoms. These atoms, an individual atom is about 1 nanometer. So you can imagine there's at least 100,000 atoms per hair follicle, and realistically it's a lot more, like maybe 200,000, sorry. And this just goes to show how incredibly small they are. And the hair follicle itself is pretty small. Now, a